Is it starting? Hello, everyone. Good day to all of you. I'm Harris. Hopefully, you know me. Of course, you know me. For those who are not familiar with my position in the Beha Futures Foundation, I'm a board member. And Eddie is not here to run this webinar. I will be replacing him. And actually, I'm very glad to replace him because the guy you're going to be listening to is actually someone I've met. Ray and myself have met on my flight to Atlanta. And when I was traveling to Tampa to visit the IEEE meeting series. And it was a really fun, actually it was a conversation in the plane that allowed me to pitch the whole foundation thing we do in Bosnia to Ray. He couldn't escape anyway. And he was trapped with me for several hours, and I had the opportunity to pitch everything to him. It was a very fun conversation, and actually Ray was the one to reach out to me afterwards when he saw I added him on LinkedIn, and we discussed how we could, help the foundation and help our cause, and he was more than willing to help this way. Ray is, for those who haven't read the whole info part, or for those who have read, I'll just remind you, Ray is a chief architect at IgnitionOne. IgnitionOne is a company that deals with, let's say, advancing and providing companies with data about their potential customers and their interests, and building the profiles on people who are visiting their webpage and looking to buy products, so they could offer them products that are built and specifically for those people. They deal with enormous amounts of data. It's very interesting from that side of things. It's very interesting because they've been working with partners such as such as Facebook, such as Volvo, Visa, Garmin, working with General Motors. So the top brands of the world have been working with his company, and he'll probably say a couple of more things about his company as well. So I hope you have joined now, and I will hand off the torch to Ray to introduce himself, and we start the webinar off.
All right, great. Thanks, Harrison. Welcome, everybody. Yeah, so as Harris mentioned, we met on the plane. We had a great conversation. It was a lot of fun. I think we had about 9 hours to kill, and but it went by super fast because we just really had a great time. Let me share my screen here as we get started. Couple of things, just some logistics. Harris and I chatted just before. We'll try to manage questions during the session today and get through those and get through some of them. I want this, please have it be interactive. If we get a lot of questions, we'll be happy to take these offline in a further session. So as Harris introduced me, I'm Ray Elenteny. I've been around for a while, chief architect at IgnitionOne. One of the things that I do tell people, they ask, "What do you do?" And Harris explained it well. And for people that say, "Well, explain a little bit more about that," and I said, "Well, those little those ads you get on the web page, we're one of the companies that delivers those." Now, there's a lot of cool data science and technology behind that, but that's the stuff everybody seems to get real quickly. If you see, you've been shopping for shoes, and all of a sudden you have shoe ads, and we're one of the companies that does that. We deal with extremely high volumes of data and amounts. We have a system that processes 400,000 queries per second, and we deal with gigabytes and gigabytes of data per day. So it's a really, really fun set of technology and application. So as you can see from an experience perspective, I've been around for a while. I love what I do for a living. I tell people I get paid for my hobby, and still do after coding for over 40 years. And I graduated from university in 1984 with a computer science degree. and started in 1985 professionally. But one of the things that I've kind of zeroed in on are product companies. I've worked for product companies since the late 80s. They're challenging, they're fun, there's pressure in a good way to deliver. I've enjoyed it. My contact information, I put my LinkedIn URL there. Feel free to hit it. If you have any questions after this, feel free to message me, and we can go from there. And I'm happy to answer any questions. So we have a really full session here. We're going to take a quick review of design patterns and just kind of introduce. Some of you may be familiar with them, some maybe not. I'll take a real quick review of those, but we're going to get into why these things matter. So especially from a long-term architecture perspective, we're going to look at some specific design patterns and what's evolved since these patterns came out way back when in the mid-90s, and have evolved since in how application frameworks support them now. So once again, the session will be as interactive as practical. I want to make sure I get through the material, but I want to answer questions that are going to be relevant at any given time in the session. So Harris will keep me honest in terms of getting through the questions as we go through this as well. So without further ado, let's take a look at design patterns. Design patterns. This book, if you're not familiar with it, first of all, if you're not familiar with it, it should be in your library just simply because it's one of the foundational books that's been written, in application development ever, right? I mean, I know it's a bold statement, but it's true. There are books that have followed this and refined these, but this is the first one. This is the book that really started it all. I have a copy of this book. And it was first published in 1994, but its origins go back into 1990. Object-oriented programming was just kind of getting rolling, and a lot of these books were written in the context of a lot of people were dealing with Smalltalk and some of these other pure object-oriented languages. And how do we tie that into an object-oriented language that works? That people used at that time. The primary language object-oriented at that time was C++. Java wasn't, Java was in the works, but it was not available then yet. So this is really a great book. The examples are in C++, and it talks about technologies that in terms of windowing technologies that some of you may not have ever heard of before, but they were really popular back in the day there. So I would encourage you to just take it. And still today, it's a good book. If you say, how do I want to solve this problem? You can read this book. I still use it. I use it when I train other developers. I use it myself when I say, I need a pattern. There's got to be a pattern that does this. Right? So how long ago was this? I thought I'd bring this up. That's Netscape. Doesn't even exist anymore. Netscape Navigator 1.0. Browsers were pretty much brand new at the time, and that's what they look like. The interesting thing there was to find websites that you could hit, because compared to date, there weren't that many. And also, 1994 was the year the first PlayStation was released. So that's the PS1 right there. And that was this at the same time. So if you're a gamer, maybe you have one of those on your shelf for as a museum piece. Okay, so the one thing I like to say about design patterns is that they look obvious. When you read a book, you read design patterns, you're like, okay, well, that makes perfect sense. But that's really a good indicator of a well-designed piece of code, architecture, however you want to state that. So over time, we know that patterns emerge as common problems are solved. Oh, I solved this one before. I solved this way before. You get a group of people together and say, you know what, we're really solving the same problem the same way. And so design patterns encapsulate common sense solutions into definition. So if you look at a design pattern, there's not any sophisticated computer science magic in them. they just make sense. You look at them, I need to do this. Oh, that makes good sense. There's over 20 design patterns, and so applying the right one may be a bit of a challenge, but each pattern itself makes perfect sense. Looking at the various patterns, they almost appear simplistic. This is why they're so useful. They're easy to conceptually understand. And it ties into the last point. The best architectures almost always appear simple. They may take months or years to develop, but when you present a design, you go to a seminar or a company meeting, and you present an architecture or design that you've been working on, and somebody says, well, that's obvious. That's probably one of the best compliments you could get with a design, because it's so simple and so straightforward. It may have taken you months to get there, but when the people who are viewing or participating in your presentation say, oh, that's obvious, it's the only way to solve the problem, you've done your job, right? And that's how design patterns are, is that they appear very simple, and you say, well, of course, I wouldn't do this any other way. So that's the key at the top level of design patterns. On the other hand, design patterns can't save the world. Like any other technology, they can be abused. A term that we have in the US here is just because you have a hammer, not everything's a nail. And it's very common. Technologists like to hop on a technology. I can be guilty of it myself, and say, oh, they got this really cool technology. I'm going to use it for this, 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 and this. That's not always the case. You really have to understand how design patterns apply. This is really just general technology, actually. And are we abusing what the original intent is for those? Like many other applications and frameworks, they can be circumvented. So people still write code, and when people write code, people can sidestep the process. So you may be a manager of a development team, you're a senior developer, myself an architect, and say, we're going to use these patterns this way. Well, crunch time comes, your code is due by Friday, and I don't have time to do this. I'm going to circumvent the code or circumvent the process or the pattern. And it happens a lot more often than you might think in the real world of developing applications. And also, it's not just the code. Code is the artifact resulting from design. It's the diligence to adhere to the patterns and principles that matter. So I've been coding for so long. For me, by the time we get to coding, we've solved the problem. Coding is just the artifact that I need to make it work. Now that doesn't mean that coding is not challenging, and there's tricky things in it and that kind of stuff, because there definitely is. It's why I still absolutely love to code. But the design is still critical in selecting the right patterns. And then finally, the process is critical. No matter what company you work for or will work for, process in software development is really critical. And so you have things like code reviews. Even at my level of coding, if I submit some code to be used in the company, I expect other team members to review my code and make sure that I'm following the best practices and I'm following the standards that have been set for my project or my company. Code analysis is another level where there are tools today. We run tools on our software that once you've committed the code and it's ready for use in the application, or at least a test, maybe for QA or something like that, we have tools that actually scan the code and look for things that may be errors. There's a lot of intelligence in these tools that may be errors, and maybe you're not following a style in a way that the business has wanted it to be done, so on and so forth. And then, of course, training and mentoring. So design patterns are fairly, agnostic. Well, not fairly. They are agnostic to technology, and so it's up to the whether it be architects or senior developers or development managers to teach new team members how those design patterns are used. And so if we're using Java, this is this, and we're using the observer pattern, this is the way we use it. If we're using, C#, same thing. We pick whatever, the language Go. Golang has been a language that I've been tinkering with lately and finding enjoyable to learn. So these are all the things that go around just using a piece of technology. You can put just about any phrase in front of "can't save the world" up there, because this applies pretty common across the board. Okay. So design pattern principles are the key. So the objective here is, like I said, that book was written using C++ and an old version of C++. Says the programming language landscape is constantly changing. There's always new languages being developed, and there are in a language such as Java or C++ that have been around for decades, they're always evolving. So adhering to the principles is much more important than adhering to the the code examples that you might see in a book from 25 years ago. So understanding the principles that they solve, and in that design patterns book that I mentioned there, does a great job of explaining what the use cases are. And there are other books the same way that build upon that, explain those. Sometimes design pattern code becomes obsolete, but that doesn't get rid of the challenge that has to be solved. Specific code used to support a design pattern may be replaced with framework capabilities. And we're going to look at that, because design patterns, the ones I picked to demonstrate with code, are somewhat challenging to develop in a very flexible way for application support. If you know today everything that your application will ever do for the lifetime that it exists, well, you can hard code some of the stuff that I'm going to show. But as systems evolve and as applications evolve, we're adding features, adding enhancements, we're changing technologies, these kinds of things. You may choose to use different frameworks and technologies to solve that problem. So design patterns in the real world. When you write an application, it doesn't matter what the application is. It's a phone app or a web app. Version 1.0, 1.0 is the easy version. It may be hard to get the idea and get the concepts, but when you write the code, it's the easy version. The overwhelming cost of an application occurs after version 1. New features, evolving technologies, new runtime environments. If some of you may be familiar with Kubernetes, it's only 5 years old. It's changing the landscape of all of deployment capabilities, the application deployments, maintenance, having to upgrade, libraries, that kind of thing. Studies vary, but on average, 2/3 of the cost of an application's lifetime occurs after the first version. So doesn't matter what kind of company you're working for, if you're doing a startup, you have to understand that depending on the model, it can be 75 or 80% of the cost of your application occurs after you deliver the first version. And it becomes very important. If you want to make some money, you've got to keep those costs in check. Sometimes, I was going to say low, but sometimes they're not low. You have to keep them in check. That balances and works within your business model, right? So, and once again, proper use of design patterns doesn't solve all of these problems. However, they are foundational to the cost-effective longevity of an application. When I do a talk in my own company on how applications, how we design applications, I use a lot of quotes, from various industry experts. Martin Fowler is a fan. I do a lot of reading about Martin Fowler. And a lot of it has to do with getting that application into production. You're not going to make any money, right? Or satisfy your customer if you're not trying to make money. Maybe you're helping a local community organization get their web page up. Doesn't matter. You're not going to be successful until people can use it. So when I work with developers, I tell them the deployment of your application begins with the first line of code that you write. So you need to be thinking always about how this is going to be deployed, how is this going to evolve, how I'm going to upgrade it. What's 1.1 going to look like? And you don't have all the answers, but you need to make the accommodations. And one of the beauties of design patterns is that you don't have to have all the answers, because you can lay the foundation in so that you can swap out implementations or add features. We'll look at this in the examples that I have today. So this is a set of principles that I've developed over the years I've been an architect and working with teams and product teams. So the first thing is building an architecture that endures. It may seem counterintuitive, but I haven't been at a place yet where an architecture that we've built has lasted less than 10 years. Seems like a long time, and it is a long time. But companies, when you work for a company and they're investing in software, they don't want to hear, well, we have to rewrite all of that. Well, we have to rewrite all of that. That's very expensive. Now, in some cases you do. There's always the exceptions, but the idea is that you build an architecture that can withstand the changes in the technology landscape. Multiple platform and deployment support. You have no idea where your application is going to be deployed 2-3 years from now. I can't tell you where our applications will be deployed 2 or 3 years from now, or how those deployment architectures will be will evolve, the ones that we are in today. Very important to understand. Enforceable standards, standard patterns and compliance. A lot of this, around the world, we have various security organizations and privacy organizations. It's very important that these things get baked into software, because companies, as most software companies around the world that deal with any type of customer data, it doesn't have to be financial data, just information about people, email addresses, something like that, are audited once a year, a minimum of once a year. And so you've got to demonstrate that you're compliant with those regulations in each region of the world that you're working in. And so an architecture needs to understand that stuff. Reuse and extensibility from the ground up. Oftentimes what I tell teams is that we may be developing application X, but we don't know what application Y is going to be like. The business might come to us with a great new idea, and we want to build application Y. So what we want to do, and I'm sure you guys are familiar with it, reuse, component architecture, and those kinds of things. It's critical. That's real. That's not just stuff that you learn in university or by reading books. Reuse and extensibility is a real concept, and it allows a business to be successful, allows a business to react to the marketplace very quickly. A collaboration with independent external modules. Nobody writes all software in an application. You partner with other companies that do things. Maybe an obvious partner would be a database. Postgres, Oracle, SQL Server, whatever your database is, or a NoSQL database. Elasticsearch, Couchbase, whatever they are. Those are external modules. Some security modules. These kinds of things. As time evolves, though, you may say, well, we're using Couchbase today, but really Elasticsearch was a better choice. So I need to be able to swap those database technologies with minimal impact to the application. Evolutionary module compatibility and upgrade paths. Once again, version 1 is the easy one. 1.1 and everything else is hard. How are you going to upgrade your application? The last one is interesting, and that is the notion of designing for obsolescence. All the code that you write today will be replaced at some point. And so the notion there is understanding that as I'm writing this code, if I'm using the right principles and the right separation of concerns in my design, I'm making it easy for the next developer, which may be me, Harris and I were chatting about this earlier, as a matter of fact, to replace the code that I wrote. And this is inevitable. This isn't a maybe this will happen. This is a guaranteed. Your code will be replaced after a certain period of time. And so understanding that is how you can, that's how an architecture lasts for 10 years, because you're constantly evolving that. One of the analogies, and I wish I knew where it came from originally, but it's not mine, is that if you know anything about big ships, Navy ships or merchant ships, often you hear, by the time they start, they paint, they start at the bow at the front, and they start painting, and they get to the back or the stern. By the time they're there, they've got to go back to the front again and start the painting. That's what an evolving architecture is. It never ends, which is great. It's a lot of fun, and especially when you can watch your architecture evolve over many years. So design patterns play a role in each and every one of these. We're not going to cover all of those today, but they play a role in each and every one of those points that I just brought up. I see a question here. So what are some of the common misuses of design patterns today? Well, that's a good question. It kind of goes back to the point earlier that I made, is design patterns can't solve the world's problems. Their systems can be over-engineered, right? I'm a computer scientist. I love, after as many years as I've been doing this, I have to fight the urge to over-engineer a system. So some of you may be familiar with the agile development methodologies, where you build just what you need to build. And so when you do that, you may introduce a design pattern as opposed, and incrementally enhance how it works. In the olden days, there was a process called the waterfall model, where you would do all your design up front, do your implementation, do a QA, and by the time you got through with that, all your design documentation at the beginning, you found it was no good anyway, because the application changed so much over the time it took. So when you go through a situation like that, where you're doing all the design up front, you are, computer scientists, once again, like to over-engineer. It's a tendency we have. And so you're going to put a design pattern everywhere, and design patterns on top of design patterns, and these kinds of things. When you want to often let the design evolve and introduce the pattern at the right time. So that's what I would say is probably the most common misuse of design patterns I see today. The other one is squeezing in a design pattern where it really doesn't fit. Couldn't solve a recurrent problem with any of the 20. That's a good question. The answer is probably yes. I just don't have one off the top of my head. What it mostly boils down to, and actually, to be honest, a lot of the stuff that we deal with today, like some of the high-speed design things that we deal with, it gets to be very challenging with some of the design patterns. Since I was coding for so long, do you believe Rust will be able to replace your? Well, I believe any language is a strong competitor to any language. That's a really dodging the question, but it's true. The issue, though, and I'm going to be candid about this from a language perspective. So businesses don't care about the language. It hurts us, right? They don't care. It hurts us. And so what they want to do is, what's the biggest pool of developers at the lowest cost? And that's what. So these examples will be in Java today. And Java right now is it's been for a long time the #1 language, which means there's the most developers, and at a grand scale, it's supply and demand. More Java developers, they're less expensive. Python developers, we have a big data science group. Python developers, very expensive in the US, right? Because even though as big as Python is, I get it, but compared to the Java space, it's much smaller. So I'm a big Go fan. I think Go has huge possibilities. But as a business person, I have to put my business hat on, not my geek hat. I have to say, it's years and years before you would see languages replace C++ and Java, simply because of the number of people that know. Not that it doesn't happen, but it's a long time. I'm a big fan of languages and study them all the time. Mentioned design patterns get circumvented as a result of external pressures. Is there a situation where it's smart to circumvent? Okay, so that's a really good question. So my answer is no. The answer to the more in-depth question is, say, we're going to apply this pattern here and basically stub it out, shell it out, write a skeleton, right? And just do the pieces of it that you need. Because if you get into separation of concerns is one of the key tenets in an application architecture that evolves. If you implement the right contracts and the right separation of concerns between the components and the services in your system, you can replace the implementation all day long, right? So I know that was a bad database, or that's some really crummy code under there. But because I've separated it with a design pattern, then it's less painful to make the evolution. So I would say to teams, okay, so if we're going to do the observer pattern, we know, as a matter of fact, the examples I'm going to show you today, because I've been coding for so long, I wrote this code specifically for this presentation. I'm thinking there's 100 things more I could do with this code, right? But that's what ends up happening. And so do just what you need to do. It also fits with the Agile framework. Now, sometimes you miss the application of a design pattern. That's okay. Put it in, introduce a separation of concerns. So I hope that answers questions. Really, really good questions. Good stuff. So let's look at some design patterns. We're going to touch on these pretty lightly because we're going to dig into some code, which is always a fun part for me. So we're going to break these down by categories. Design patterns, depending on what book you read, have 3 categories of patterns. The original, again, that's called the Gang of 4 book because the 4 authors, the Gang of 4 design patterns book, has 3: creational, structural, and behavioral design patterns. So singletons and prototypes are in the creational pattern, and I have to sprinkle in a little bit of an abstract factory pattern in there because that's how it all works, how they all work together. So creational patterns are foundational to an application. This is the part where there is some discussion when you build applications on this, but this is an example where you cannot compromise in there's always exceptions. So you'll never hear me say guaranteed or never. You cannot compromise how your objects or types are instantiated with in your application. It's extremely important. It sounds simple, but as we're going to look here, you're going to see how important something as simple as just creating an object is within an application. So the thing about creational patterns is that they abstract the instantiation of objects and types, okay? Enforces decoupling and the separation of concerns. We'll look at this, and there's different languages can accomplish this differently. There's C# and Java are very similar. Go actually blends a lot of different things. This applies in Go as well. Some of the stuff I'm going to take a look at here, but it's about decoupling and separation of concerns. You've heard me talk about this in the questions. So singletons, prototypes, and abstract factories are related. So it may be implied when you look at this is that I need a factory to create objects, right? And so that's the way to look at this. And we'll look at the singletons and the prototypes in a sec. So what's wrong with new? Nothing. If you have a basic type, we just need to create a list of something or a dictionary or a map. New is great. But business services and business objects are different. We need to separate the implementation of those entities and those services from the contract. So I can replace the implementation of a business service with something else. I can go from Couchbase to Elasticsearch, for example. For those of you who are familiar with unit testing patterns and mock implementations, if you follow this pattern, these creational patterns, it makes your unit testing of your code much easier to do. I'm not going to demo that because that's a whole session. I've done sessions on unit testing in the past. There's a whole session itself in unit testing, and of course, evolving supporting technologies. I've mentioned that previously. So those are at the high level. What the three aspects or the three patterns we're going to look at for our initial example set. Now, for my examples, this is always one of those things where I'm going to stop the presentation here real quick. And I'm going to bring up my IDE. I happen to be using IntelliJ as an IDE. This is the project that is in GitHub, and so you can bring it down. So like I mentioned, it is a Java application. IntelliJ, I happen to just buy my own personal license because I love the tool so much, but there's a community version you can use as well. There's Eclipse, if you're not familiar with that. There's also Visual Studio Code. There's a lot of ways that you can run this project. But the way this project is broken down is that we're gonna look at these three sections we talked about: behavioral, creational, structural, and then application framework. Okay, and some of this stuff is well, one of the things about design patterns is that they tend to get abstract. And so I tried to come up with an example that we would all understand, so we don't have to worry about the example. We can focus on the abstractions. Even given that, don't feel if you feel lost, right? If you feel like this is, I'm confused, that's very natural. You should not be discouraged on that, and we can follow up with specific questions afterward, because design patterns do require a particular way of doing things. So my example is a media player with albums and songs and videos and pictures and that kind of thing. So we get that sitting and working my home sitting right next to me. I have a big Plex server with 16 terabytes of disk for my media server here. I said, oh, that'll be a good example. So we're going to start with the notion of a prototype. So a prototype is an object. Now, depending on, there's a lot of different ways of looking at this, and this is one of the ones where everything has an application within the technology. So a prototype means that every time I ask my factory for, in this case, a song, it's going to give me a new song, right? A new instance of the class song. So I'm saying here, media factory. We'll take a look at that in just a second. That's my abstract factory. Create media of a song type. And see, there's no new here, right? And I'm printing out the type, and I'm printing out the ID. Because figure if I store this in a database, I'm going to need a key to store this in the database. If I'm asking for another song, the type should be the same, but the ID should be different, because that's a new instance of that song. Okay, sounds very obvious, because this is probably the most common use case. This is just newing an object, for lack of a better term. A video here, I want to new a video. So if I just go ahead and run this, and I have run these things like 10 times today, so let's hope that everything decides to work really well through this. And ooh, that's kind of small. Let's see if I can do. Oh, I can't make that any bigger. It doesn't look like it. Sorry about that. I should have checked. Nope. Trying. So what you'll see here is the media type is song, and the IDs are just GUIDs, right? So even though these are two songs, I have two UUIDs, right? So this is very basic. So let's take a look at the media factory, create media. Well, forget about the language, the syntax for now. You guys can all explore that later or ask me questions about it later. But what's it doing? Well, it's just doing a new. Okay, well, that seems kind of silly. Why couldn't I just do it? Well, we're going to build on that. So, but what I've done is I've abstracted the creation of albums, songs, videos, and pictures into a factory. So now I have the ability to create, maybe there's a new type of album, album 2 or album, next or something like that. But if it's, as long as it's an album of type album, then I'm okay. I can create those all I want. So this is a very, very basic case. Okay. Interestingly enough, let's see if I did it here. This is in Java. This is also the application of a singleton. We're going to look at singletons in the next demo too. But a singleton, when you look at this syntax here, by putting a private on the constructor, means nobody can instantiate this object. Right? And I just have one method in it that's static, that without instantiating the object, I can execute it. So that's a static singleton. So we're going to look at the singleton demo. We're going to go a little step further here. We're going to create a media server, right? So I'm going to say so media server dot get media server. We're going to take a look at that. This is our singleton object, and if we look at the media server, what it does doesn't. We'll look at what it does later. It's extending an abstract class. This is the part that makes it a singleton. In this case here, is that when this class is brought into the Java virtual machine, the first thing it does is it creates an instance of itself. Okay, this is Java. This is once again Java pattern for singletons. And then when I say get media service or server, I return the static instance that's been created. Okay, so if we run this, it's going to say, oh, what's the size of the catalog? I have here's an example of a new, I don't want to go overboard with all the singletons in the prototypes. We've got enough to deal with here. But I have so given a media server, build a database, and it's just building a bunch of, silly examples. If you look at the code, they're almost all stuff from the 70s, but I didn't realize that until I started doing that, but except for one of the movies. But then I can go, so if I built a database, I should get a size of that catalog, right? Or I get the guys, it should have some data in it. If I do media server, get media server again, the singleton pattern says I should return the same exact media server that I did up here, which means that the catalog will be exactly the same size. Okay, so pretty straightforward stuff. So if we run this, we see first one here. So we see media catalog size is 0. The second time we added 39. We've added 39 items to our catalog, and we ask the question again, and we say, and we still get 39, which is what we should get. So then I have a display catalog, which goes in. Once again, a lot of this is going to be, if you choose to run this stuff, you'll see, what this is. So I've got, songs, and I'm a big Beatles fan, big Pink Floyd fan, and that's what you'll see here for a lot of the songs. So very simple. That's a singleton, a prototype, and a little bit of abstract factory. And these are the basic patterns from which the rest of these examples we're going to build upon. When you look in here, the way I've separated these projects, separated the packages in these projects, is that the model package is kind of the, so if I look at the prototype here of song, okay, here's a song. It extends abstract media, which implements media, because the contract is media. So in Java, contracts, and Go, many languages, it's C#. The contract is the interface. So in this case here, album, picture, song, and video all implement the interface media. So that's our separation of contract. That's why I can replace album with something else, because as long as the next album satisfies the media interface, I'm good to go. And so, and then our singleton you already saw with the media server. So that's I tried to break these out, and so this is kind of the definition of the contract and some base classes, because you don't want to write a lot of boilerplate code. And even the media server implements a extends abstract media server, because we have more than one media server here, and which implements the interface basic media server. So once again, in Java, interfaces are the key to separation of concerns. Okay, so let's go back to our presentation. So get some going. So now decorators. This is actually one of my favorite patterns in application development, because these are super ultra powerful. They get to be a little bit abstract, but they're super powerful, and these are one of the things that teams and really help application projects move forward quickly. So decorators, I call it functionality for free, right? So decorators extend an object's capabilities without adding code to that object. Once again, we'll have examples on that. They provide a flexible alternative to subclassing. Object capabilities, so the object capabilities are dynamically expanded at runtime, not at compile time. So you can change the behavior and the capabilities of an object at runtime. So no additional code in these kinds of things. They're all often used for what's called cross-cutting concerns. So measure the performance of a method. How long does it take this method to execute? Validate the authorization to execute. Can Ray execute this method? Maybe it's a security clearance required. Log diagnostic information. These are the kinds of things that you would use. So you can apply decorators to wide swaths of code and just kind of get it for free. Get this capabilities for free. And the key here is once again, development, if you're working for a company, everything's about dates. Right? You get to, it's funny because I've been doing product development for so long, I keep very few calendars, because everything in my life is about dates. For my business, is that often my calendar is pretty much in my head. That's how much you get baked in, how much dates get baked into it. And so so what happens is that, if you as a designer say, hey, we need to measure the performance of the methods in this class, or we need to make sure that Ray can, or users of this type can execute these. Well, the challenge there is that when the time comes and push comes to shove and the deadline is right around the corner, these are the details that fall through the cracks. A developer doesn't intentionally forget, assuming they're good developers, not malicious, right? Doesn't intentionally forget to validate authorization. They don't intentionally forget. What happens is that they're under the gun. The code's due tomorrow. They just forget. So the things that decorators do is it says, okay, developers don't worry about it because we got it for you. We have a set of decorators. We got it for you. You're good to go. Decorators, there's also a term, so cross-cutting concerns come from the aspect-oriented programming paradigm, or AOP. So decorators are a subsection of AOP. Many applications suffice with the decorator pattern. Some sophisticated applications, if you're getting into AOP, topic for another day, do a lot more than just the decorators. But if you hear decorators and AOP, or decorators, cross-cutting concerns, these kinds of things, a lot of times they're used fairly synonymously. There's subtle differences, but you can see that. You'd see that when you dig in. Okay. I'm seeing somebody. Some beautiful thing. Loves the decorator pattern too. It's one of my favorite. Okay. So does anyone see the pros and cons? Oh, okay. Using this design pattern. It's just a question out there. So let's look at our next project, which is structural. Okay. So what we want to do is we want to do two things with our with decorators. We want to make sure that a user has, let's say parental controls. You should put parental controls on your movies or something like that. And I don't want in my case, my grandchildren to be watching a movie of a certain type. And so we have a media rating decorator. And then I'm also going to add a decorator that's a plays decorator. I want to record how often this movie is played, or this album, or whatever the case may be, and then get a report, occasionally. Now, obviously, quite simple here. We're just going to report to the screen. So if we look at this basic case here, I'm going to go. We have the notion now. We're introducing into our media server the capability of a media player. So a media player, in a simple example, has play and stop, right? We're not going to get really sophisticated here, all right? So traditionally, in the patterns, when you look in a book on display patterns, display patterns, on design patterns, what you'll see is that the decorators often have to implement the same interface or extend from the same abstract class as the entity that's doing the work. So if we look at the media rating decorator, it also implements media player. And when we go through the example, you'll see how this works. And so quite simply, if it's play, here, I'm creating a fictitious user session, and my user session so I have this media, and I'm asking the user session if I'm permitted to run that. If I am, play. If not, I do a little bit better error handling in a real application, but this exception is good enough for now. And for stop, it's just gonna go to the next item in the chain. So think of decorators just simply as chaining. You can think of them as proxies. In the Java platform, decorators are supported by proxying codes generated dynamically by the JVM, Java Virtual Machine, to proxy decorators. So this is a right out of the book, not leveraging the language platform. We'll actually do that in a little bit. Plays decorator, same thing. I'm going to have a plays metrics singleton here that is just going to keep track of I've played this media. So pretty straightforward. So our demo here, we're going to run through this demo, and I've got a random play videos method in here, and we're going to get our media server. I have a class in here that's going to say initialize the decorators, and what you'll see here is the decorator is pretty straightforward, right? It's just I'm creating my different players here, and so I've got a decorate method around each of the new. So now you can see that I have my abstract class, which was creating these objects. Now, well, actually, in this case here, I'm actually newing these, so I can actually go all the way through this in this case. But now I'm decorating the album player, decorating the song player as opposed to album. I should say, I got a little confused there. Sorry about that. Is that this is a different way of instantiating these objects, but now they're going to be decorated. And what does decorate do? It's very straightforward. So we go to decorate handler, decorate, and hang on a second. Let me find the one I want. We are in structural. So we're going to look at the decorator handler. And it's very simple here. So my decorate handler, the way I'm decorating the objects is I'm taking something that implements the media player interface, run and stop. And I'm instantiating the plays decorator, passing that object, because it implements media player. I can do the same thing, the media rating decorator, passing the plays decorator, and I can actually return the rating decorator as my media player. Okay, because it satisfies the interface. And so as long as I'm satisfying the interface, then my class can just simply just use them. So once again, here I'm doing a random of the video. So let's watch this in action. I'm saying PG-13. I only did 4 movies on here, but let's watch and see what happens here when we run this. Okay, so what we see is playing video, playing video, playing video. Here we say unable to play Inception, the movie Inception. It's rated PG-13. This could take a list, but I'm just, for this use case, I'm just passing one in here. So you can see it's going through and playing the different videos, throwing the exception when I played these. And then at the end, media played metrics, I'm doing the play metrics report play. So we know that the play a plays decorator has been invoked. So if we do something here and we debug into these, let's kind of see how this works. We're going to just debug into this. So we're going to see here we are in our media server. We're calling play, and our media player isn't a media player, it's the media decorator, but that's okay because it satisfies the interface. And once again, it satisfies the contract. So it's going to go ahead and run, and then we're going to get into the plays decorator. Right? So the plays decorator has it is, if you look at the stack here, so the media rating decorator calls the plays decorator, and you can see up here, if we go into the video player, okay. So we're going to say that we played this, and we do a next. Now we're in the video player. So without changing the video player, we've added metrics and metrics, plays, metrics, and we've added a rating decorator. The nice thing about this is I can replace this code back and forth, right? So maybe there's a different rating system. Maybe I'm using a different database to get the ratings from. Maybe my plays service that's logging metrics, it changes. So all of those things are perfectly fine. It can handle. The video player could care less, right? Because it's all handled within the app, outside the structure of the application itself. So we're just going to let that finish. Actually, not stop at all the debug points anymore, and we get our output just like we did before. Okay. So now let's look at our third pattern, our third section of patterns, and we're going to bring it all together in the final example. So, I didn't show let's see some code. The observer pattern. This is another important pattern. Many applications implement this, for all different kinds of reasons. So the observer pattern is often used to say what changed when. Something changed in the application, and I'm interested when that changes. So it's publish, subscribe. So I'm interested, I'm going to publish my interest in knowing when something changes. And then when something changes, I'm going to receive an event that it changes. Other objects subscribe and are notified when the event occurs, as it says. It defines a one-to-many relationship across object instances. So my video player, for example, doesn't need to know who's observing when I'm about to do something. Okay, as you say, avoids tight coupling when looking to provide consistency. If you know the model view controller pattern, so the observers are considered the view components in MVC, and so when the model is changed, the views are updated. That's where it's often used here, and that's the kind of the example that we're going to talk about here as well. So the observer pattern in action. If we look at behavioral now, we implemented this as a decorator, and what we're doing here is we have an observer decorator. So it's follow the same exact pattern as the previous decorators. Now we're just adding another one. And we're adding a couple of observers here, a logging observer and a presentation observer. And those, like everything here, are fictitious objects, right? But I mean, they're real objects, but they don't do much. So the logging observer would be, yeah, every time something's played, I want to be notified so I can log it to my diagnostic logging system. Or when something's played, for example, I have Plex, my media server's Plex. And so, for example, if something's played, I want the dashboard to be notified. So the dashboard shows that, I'm now watching 2001: A Space Odyssey, or somebody on my Plex server is watching 2001: A Space Odyssey. And so the video player, I don't want the video player to have to deal with that detail. I want the system to react to the changes. And I happen to be implementing this as a decorator. You don't have to. There's a bunch of different ways to do it. If you look, there's lots of examples of observers in the internet in these books. But this is how I chose to do it, just to kind of keep everything going, building on what we've done so far. So if we look at the observer demo, the observer demo is exactly the same as the behavioral demo that we just showed. The difference is we are now adding the observer decorator. So now we've got 3 in this scenario. So hopefully this makes sense. Looks good. Then we've got our observers here, which are doing nothing than printing out some information, and a presentation observer that says, oh, I need to display media, get name, right? So we're going to get this same output that we got from the previous run, but now we're going to get more output because I'm now logging the play of Star Wars. And I'm displaying the media Star Wars, and then finally the video player is playing it. So everything is, and then once again go to my metrics. My metrics, my player stats are still there: 4 plays, 3 plays, 2 plays. So we continue to build on the system without changing the players. Right? That's what's cool about decorators, and these are very critical aspects to a system as you grow a system and introduce these things, often called cross-cutting concerns. I want to know every time something's played. I want to notify the UI every time something's played, for example. That's what we're doing here. So we've got our 3 basic examples, and now we're going to step it up to, because the reason I'm going to say that is because if I look at this, when I say code doesn't change, well, technically I'm wrong, right? So the video player doesn't change. But if I add a new decorator, I have to update the media decorator handler in order to add the new decorators that I have. We want to be able to get to our application. I've come to the point that it says, okay, I need to decorate this, media player. Who's interested in decorating the media player? So the application code is actually going to say it's going to discover which classes, which decorators to apply to the media player. Because here, I've got to know which ones to apply. They have to implement media player. So that means I can't use them for anything else. Like if I want to do a logging thing, and maybe I want to log all methods, or I want to validate the metrics on all applications, well, I'll have to have an interface for every type of business service that I have. This gets almost just as unwieldy, right? We're going to get rid of all of that and make this so everything is self-discovered in the application. So for the first 3 example sets we've done here, this is what you'll see, and perfectly valid, to demonstrate those patterns. But how does this work in an application where you have hundreds of thousands of lines of code, and you just, this is something that can get missed. So design patterns and application frameworks. So when you get into big applications, frameworks, application frameworks come to the rescue. As I mentioned, design patterns require adherence to convention. It can be done, but it depends on code reviews. Over time, teams changes, style changes, the pattern implementation will change. This will lead, or may, to poor application of design patterns. It's just the evolution, because if you have 500,000 lines of code, there's no way that even the most senior architect or developer is watching all that code. You can't. That becomes a bottleneck. You have to trust your other development managers and your senior developers and your application architects that they will evolve the application properly. So as we mentioned, they do require an adherence to convention. So most languages and platforms actually accommodate design patterns in a way that helps architecture team members and designers to enforce design patterns and how they're used within an application. And so, as I said, so most languages, it's kind of a tip your cap note to design patterns. Most languages and platforms accommodate design patterns. They recognize the importance of their application, and even beyond that, there's frameworks that nobody writes. And if you're writing a big, huge application, you don't use, you don't write everything. You don't write a database. You don't write logs. You use a lot of components. Well, an application framework is just a component that says this is going to be the model of how we develop our application. That's once again topic for another discussion, but I'll show you a little bit about that in a little bit. And coming up here, this is the example that'll put it all together. So platform implementations of design patterns may vary. It could be a part of the language. It could be part of the specifications, maybe part of the runtime environment. All depends on the platform. One of the reasons that I'm actually a Java fan is, and I know Java kind of loses its luster. Java's been around for 25 years, so it's obviously there's a longevity factor, and even beyond the number of developers, so Java does react to the market. But one of the coolest things about Java is Java's not about the language. Java's about the platform. And you need to use the language, but you can use Scala, you can use Java, you can use Kotlin. There's a lot of languages you can write on the Java virtual machine. The key is that Java and the JVM is actually a platform of specifications that says if you're going to do abstract factories, I'm going to call it sticking with the terms, this is the way you do it in Java. And there's no code. It's actually just a definition in terms of how it's done. So if I want to implement an abstract factory one way, and the guy down the street wants to implement an abstract factory another way, or the lady across town wants to develop an abstract factory their way, that's perfectly fine in the Java world, because the implementations can vary as long as you follow the spec. And we're going to pay attention. We're going to look at this, and this is why I'm spending a little bit of time on this, because it's a very important part of how a language and a platform support design patterns and the ability to be able to evolve the application of those design patterns. So let's take a look at some code. Where are we at time-wise? 20 minutes. Good. Because this is probably the most abstract one. Let me check. Stop. See if there's questions. 3 billion devices do run on Java. That is correct. If you are a language geek like I am, you do, and I read, just as people ask me, I've been doing this for 40 some years, and 35 years professionally. I do spend still 10 to 15 hours a week in study. It never ends, and fortunately, it's my hobby, so I love it. So that's the key here. And so I'm a language geek and a framework geek, and so it's one of those oxymorons in the world, because everybody says, oh, Go is better, or pick your favorite, whatever your language is better than Java. Java continues to outlive a lot of those languages simply because it evolves. This is a good point. So let me get off the Java soapbox. What are some, you know what? That's a great question. What are some of the study resources I use? That's evolved over time. Because I consume a lot of information for my job. I see an article on DZone or InfoQ. I have to cross the business landscape as well. You know, what are C-level executives thinking? Because often what they're thinking about a technology, it's not that they're dumb. It's just not their specialty. They'll have the wrong notion on whatever that technology is. So I know I'll be asked about that question. So I had to dig into it. But often what I do, I subscribe to a number of YouTube channels because I watch a lot of webinars. I watch conferences because there's tons of conferences, 2-3 weeks after the conference is over, all the sessions are on there. And so even for my team, I call them lunchtime videos. I try to find videos that you can squeeze in lunchtime, 45 minutes, gives you an idea, 45 minutes to an hour, gives you an idea about the topic. If I'm interested in the topic, then I start going to wherever their website is. And then, of course, Stack Overflow to find out what's going on. So it's a navigation. So I consume way more videos because of everything I watch. I'm interested right now, if you will, with maybe 10% to 15% because it applies to something I'm doing now or maybe within the next 6 months. So it's kind of cast a wide net, but just take in a few fish and then continue to do that. I rarely buy books anymore. There are books that I do buy, but to be honest, by the time the book is out, often the technology has advanced too far. But I still do buy books, but it's rare anymore because especially books on buying a book on Kubernetes or buying a book on Docker, buying a book on Elasticsearch. I mean, by the time they get the book written, Elasticsearch is 2 revs past. So great for current stuff, but my books are on theory, on practice, like continuous integration, continuous design, or deployment, design patterns, theory, because theory rarely changes. It's the technology that changes. Good question. So if we look at the framework project here, module, there's a new module that seems to be different than all the others. Yeah, exactly. It's Java. I mean, Java used to be released every 2 or 3 years. Now it's every 6 months. It's crazy. It's a great question. Great observation. So Juice is a framework, and I've tried to look for a very small framework because there are examples, and Java has big frameworks that encompass so many different things. But for design patterns, Juice is perfect because it's all about instantiating objects and having them work with one another. So any application framework is going to have something like Juice in it, Google Juice. You can read about Google Juice. It's extremely popular. We use it here within within our company. So we'll talk about that a little bit. I won't spend a lot of time on it, but that's what we're going to use as our application framework. So now our model has changed a little bit. So now we've introduced an interface called Decorator. Okay, so now I don't need to know that it's a media player. I don't need to know any type. If you're a decorator, if you want to decorate stuff, you can just implement this interface. That's all you have to do. Decorate. You get a question. Say, are you interested in decorating this class or applying your patterns to this class? You get it and say yes, I am, or no, I'm not. Precedence becomes important because you saw the order in which I introduced those decorators in the hard-coded example. Well, it doesn't matter. I mean, in our example here, I've got to validate that you're authorized to watch that video before I log it as a play, right? So I need to know what the precedence of that decorator is. And finally, when I invoke the method, I've got to actually do the work, okay? The other one here is media server. Now, if you're, media player. Now, this is the same media player interface. Some of the interfaces are replicated across the projects modules simply because they serve different purposes, even though media player elsewhere does play and stop. But what I've done here using Java is said, okay, so now anything that implements the media player interface and then the play method, you see the @ signs, those are Java annotations. And we're going to look at that code, and what our decorators are going to do is say, yeah, I'm interested in decorating that class or instances of that class, but I need to make sure that, so when play comes, I'm going to look and see, okay, is my annotation there? Now, this isn't absolutely required, but this is a very common way it's done in Java. But you see, stop has no annotations because none of my decorators are interested in stop. Okay, so the decorator then becomes, if we look at media rating, so our decorates class says, okay, I can use reflection in Java. I can say, get me the methods of this class. And if any of those methods have the annotation media authorized, I'm interested in becoming a decorator of that class. Okay, so that's how the dots get connected. And then invoke, I look to see, because there's two methods, right? So invoke the method. It says get annotation media authorized. If it's on there, then I'm interested. So for example, stop doesn't have that annotation, so I'm not going to do anything. It doesn't matter to me. So just only in the case where this annotation exists. Okay, and the implementation is exactly the same. Observer decorator does the same thing. In terms of, it's the same exact pattern. The logic is exactly the same. Okay. So this is what an annotation looks like in Java. You can take a look at these. There's no rocket science to them. You can develop. You can give them your kids' names or your friends' names. It doesn't matter. Whatever you want to do. So the one thing to look at here is that we are also annotating decorators because it implements the interface decorator with this thing called named. That's Java. That's in the Java specification. That says this is going to be a prototype object. So think of our creational examples where we use a factory to create prototypes, and every time I create one, I get a new one. This is telling Java that this object, instances of this object, are prototypes. Every time I ask for one, I want a new one. Okay, all the decorators are like that. As an example, or as an alternative, here is a case, and the reason why, because the @name basically says I want to have this be a factory class, but because I didn't have the @singleton annotation on it, it's going to create me a new version. So in this case here, just as an example, the logging observer is addressed with @singleton. Now, if you look here, you can see the singleton interface, the singleton annotation comes from Java. Java with extensions is JavaX, but that's why the platform becomes important. So whatever application framework is running under this is going to notice that, oh, when Ray asks for observers, I only need to instantiate the logging observer once, right? So you'll see there's no factories in this. There's no decorator handlers. In this example, there's none of that because now the application framework is doing all of this for me. Okay, so and so for prototype, I copied these items because I had to do the same thing because my album is a prototype. Okay? Every time I ask for an album, I want a new one. My album player is also a prototype. Every time I ask for an album, a media player that's an album, knows how to play albums, I want one of those. So once again, all the factory methods are all baked into the platform. Here, the implementation of the @name Java specification is being provided by Juice. So that's where Juice comes into play. Right? I could use Spring has one, the Java has one, Red Hat, IBM has one. They all have different implementations for this. And if I change from Google Juice to Red Hat has one in the product called Wildfly, I wouldn't have to change this code. It'd still be @named album player. Works exactly the same way. And my media server is a singleton because I only want one media server for my whole application. And my plays metrics I didn't do anything with here because we have enough of an example. So what you have to do, and most applications frameworks do this for you, is so I created a fictitious application framework class that's basically booting up, in this case, the Juice application module. You would rarely see this kind of code in your framework because this is what frameworks do, is they boot this up. But now I'm just going to say, get this component. I'm going to get a component of type whatever it is. I'm going to get a component of type that has a certain name. So when we looked at album, the name was album.type, which is album here, right? And then maybe I want all the media players, for example. Get me everything that's a media player. And this would be an example of that, using an application framework to do that. So this is kind of the guts that you would typically not see in an application because the framework is providing that. I just wrote these basic methods so that we didn't have to bring in a big, huge framework. So if we look at all the examples that we started with, and I did this intentionally, so as you guys work through this stuff and play with it, you can look at this. You can see now what I'm doing is I'm booting, if you will, the application framework with a YAML file. So in this case here, just for simplicity, I'm including the YAML and the executable. Most frameworks, the YAML is an external file, or JSON, whatever you want it to be. And so basically it's saying, if it's media, these are my implementations of media. If it's a media server, this is my implementation. If it's a media player, these are my players. So there's not a lot of rocket science here. It's pretty straightforward. But now the way you wire up an application, that's what this is called here, the way you wire up an application is now external to the code. So I can change, you can see there's 3 YAML files here because we're going to use 3 different wirings, and we're not going to, and none of the code changes. So what I get here now is I'm doing a get media application framework, same exact demo as I did before, except for now I'm using the framework to get the component. So when I run this, I'll get the same exact examples, right? Media type song, my different instances, video, different instances. So this is the prototype method in action, but there isn't an abstract factory that I've had to write to know how to instantiate all of that. The framework is instantiating those. So singleton demo, same thing. Get my framework, and I'm going to ask the framework for a media server, an implementation of media server. And so I'm going to get the same exact responses because this should be a singleton, and I'll get the same exact responses. So I get, I'm sure you all remember the original set of responses, but I get media size, catalog size 0 first, 3939. Once again, there's no hard coding of what the implementation of that is. Matter of fact, let's take a look at that. If we debug into this, that player media server, the implementation of that is, if you look here, is actually media server. So it's our class down here. So that's the wiring it did. This is the separation of concerns. My interface is player media server. In this case here, what I've wired is that the media server class is my implementation of the player media server, so on and so forth, okay? So straightforward from there. What did I do next? I did decorator. Next up, the decorator demo. So the decorator demo is exactly the same. But if you'll notice here in the media server, I did nothing about decorator handler. There's no creation of a decorator handler, register decorators. None of that exists. Also, too, the configuration file has changed. And so the decorator says, oh, so who implements the decorator pattern? And these are my 2 implementations. I've also added a method here that says if it's the media player interface, I want the framework to decorate it. If it's the media, I don't, so on and so forth. But I'm interested here. I want the media player interface to be decorated. So we run the examples here. And we're going to see the same output that we got before. Media play metrics, everything's the same. So how does this all get wired together? If you look here, I have a media player that is being instantiated, right? So there's no factory for the media player. The media player is also being instantiated through the factory. And I'm just calling play. So how does everything get wired up? Well, it gets wired up by the fact that I have my observer decorator. And with the observer, let's just actually step into this here and take a look how this works. Stop this. I'm not doing observer yet. That's the next demo. I didn't show it to you yet. Let's look at the media rating decorator, right? So what I'm getting here is the class is video player. Okay, it's a prototype. So it's a video player enhanced by Juice. It's using some Java virtual machine stuff, but it's a media player. And I look through here and I say, okay. If I run this through here and I see what the method is, so my method here is my play method. Question: easier to maintain code versus efficient code? Absolutely. This is as a matter of fact. First of all, this is a really good question. The Java virtual machine here is extremely fast in doing this. One of the cool things about Java as a virtual machine is that it's constantly recompiling the code into native code. When it's running, it detects the patterns and compiles it and determines what the patterns are in the application. So you get the benefit there. But absolutely. Now, there are some inefficiencies I've done in here simply from a coding perspective. Every time you instantiate an object, you probably wouldn't call this, but I'm doing it here for a use case. So the key design pattern here is don't over-optimize until you know where the problems are. Get it to work first, get it to work fast second. But for maintainability, absolutely. Unless you have a burning, super critical need for performance, this will override a performance need to have this kind of flexibility. That's an excellent question. Okay. So, and then we go ahead and do that. Actually, I didn't stop in here, but that's okay. If we stop in here, let's do that once. And we see here the annotation is there. Hopefully we should get a. Oh, I don't call stop anywhere, so never mind. But the application it gets called when the method is called and determines what to do. The output's exactly the same. So our final example is our observer, and we're going to say, oh, I have a media player observer interface. Media player behavioral. Oh, it's in my behavioral. It has a media play event is the method, right? So the observer decorator is a little bit different. So we're going to instantiate this, and we're adding what are the implementations of my media player observer. Okay, I have a logging and presentation observer. So when the media player, and we've also added observer decorator to our list of decorators. Right? So the observer decorator, the first thing it's going to do is when actually it's doing this as an execution time. You probably wouldn't do this for a performance system, but I'm just doing it here for example. Is I'm saying get me all the implementations of media player observer, and what's going to happen now is that when the method is invoked, I'm calling media play event on those implementations, right? So if we debug into this, where's my demo? Observer demo. Let's do a debug. Okay, so now my media play, I know what the media is because it's my first video. It's Star Wars Episode 4. And my observer here, is my logging observer, right? So that's my first one. So if I step into that, I will see that I'm in the logging observer, say logging play, right? If I run this again, I'm in a second one, and I am in my presentation observer. Step into that, and you see display media. And so that's the implementation here. So there's a lot here to digest, and we're 1 minute over time, and I apologize for that. But this is taking an application framework in Java, leveraging what the platform gives you and the capabilities of the platform to remove the hard coding of the, and it's really called wiring, to wire your application up external to code. This is very, very important. So that concludes my presentation. And so we've gone slightly over, a couple of minutes over, and I do apologize that I try to respect people's time. If anybody would like to stick around, and I don't know how you are with time, Harris, I could answer 1 or 2 more questions. If not, I'm happy to connect with people offline as well. Just hit me up on LinkedIn or even on GitHub. So Harris, I'll turn it back to you.
So first of all, Ray, thank you. This really was a lot of information to digest, and for me, being a computer engineer and computer science student myself, in my final year, this is a lot of information to digest because I don't know about other faculties, but at least at my faculty, we have never been explicitly taught design patterns.
Mm-hmm.
It was mostly mentioned along the way in certain projects, but now when I'm slowly getting into the industry and the real world applications of software and writing code, you understand that separating things and making them independent to facilitate them being easier to change in the future is very important, because it in the long term it really reduces costs and allows more people to work on it. I would really like you to answer 2 of the questions that we have left, if you have the time, because they're pretty interesting.
Yeah.
Are you okay with that?
Yeah, sure, absolutely.
The question was asked by Nina. She asked, did you ever need to create your own idioms or patterns?
Oh, yeah, I did see that question. I guess the short answer to that is yes, but it's a matter of combining patterns into kind of a super pattern, if you will. We use it. And you'll see also there's a pattern that exists called the model repository pattern. You can read about it in a number of places. So I have to always preface it with Ray's opinion. The model repository pattern is often documented is a shortcoming. They skip a lot of things. And so the model repository pattern for us is something we've done. We've combined multiple design patterns, a lot of dependency injection like you see here, and separating persistence with domain models. You get into the fact that when you have a domain model in your application, how am I persisting it? Or maybe it's persisted across, we have a system that's persisted across 2 databases, but it's 1 domain model. So in that case here, we've developed what's called a model repository pattern that actually leverages injection that allows us to swap the implementations of our persistence mechanisms and how we translate between our domain models and our data access objects as well. So that's kind of in short. So basically it's kind of we've created like super models, if you will, where we've combined, it's a composite model, maybe combined design patterns and created one.
Yeah, so it's more of a thing of combining things that you like that have already been developed for such a long time to be so simple in something, with a different purpose. And we have another question coming from Zorana.
Yep.
Top technologies for the next 3 to 5 years.
Well, that's a really good question. The short answer is I have no idea. Right. So, and I don't mean to be tongue in cheek or facetious with that. This industry evolves so quickly that when we do roadmaps in product companies, we do it 18 months. And we know that beyond 6 months, that roadmap is very fuzzy. Right. So we keep our focus on 6 months. Now, as an architect, I've got to look 2, 3, 5 years ahead. 5 is kind of long, but 3 in terms of, okay, this is an interesting technology, that kind of thing. So for me, the top technologies for the next 3 to 5 years, I would say, are the continued evolution of containerization. In Atlanta, I'm a Docker community member. I also participate in the Kubernetes groups. Containerization is taking the world by storm, and we're just at the tip of the iceberg in terms of what it's going to do for the software industry. That's a wave to ride. I tell people, whether you're in operations or you're a software developer, you've got to have containerization on your CV or resume. That's going to, especially nowadays, because it's still so new, you're going to get a lot of people interested in you if you have that kind of stuff. And so from there, stemming from that, so for example, Java is evolving. This is one of the reasons why Java stays relevant. Java understands that the runtime in a containered environment is different than just sitting on my machine here. So the Java platform is evolving to be more efficient in a container. So what does that mean as an architect? What's the new aspects of that language? But it doesn't matter if you're Go or Java or C# whatever. You need to pay attention to what your favorite platform is in the container space. Along with that is another technology. It's closely related to containers. It's called serverless. Many of you may have heard the serverless technologies. AWS, Amazon Web Services, has something called Lambdas, but Kubernetes is introducing a serverless platform. And so what that means, you want to run a job real quick. I don't need a big application framework. I just want to run a job that maybe moves a file from here to here. I don't need a big server. I just want something to notice there's a file there. Bam, bam, it's done. It's gone and it's done in no time flat. So containerization and Kubernetes, the orchestration of those containers, serverless. Those are very broad, but that's how you have to look at it. And then within your sphere, what is your platform that you're using today, and how does it fit in the arena of containers and container orchestration?
I think this is as much of an expert answer as you can get at this moment. Not being super precise, because you're pretty well aware of the whole complexity and the speed of everything that goes with. It's pretty much an area that has potential to be great and to be an essential part of our software development lives and careers in the future. I think with that we have come to the end of this webinar. Ray, thank you once again for devoting the time and effort to go through all of this, and thanks everyone for joining us for the webinar. Or as I've already mentioned a couple of times in the chat, I've forwarded you the GitHub link, and I will also forward everyone a short email with all the materials Ray forwards me. I'm going to try and get a couple of more resources from him in our conversation after the webinar, and I will send them to you guys so you could be learning in the future. As Ray mentioned already, don't hesitate to reach out to him and contact him. As you've seen, he's very communicative and open to sharing his knowledge and experience. So use the opportunity.
Thanks so much for having me. I thoroughly enjoy this, and I look forward to maybe hanging out in one of your future presentations as a participant.
Yeah, why not? So thank you.
Absolutely. Take care.
Take care, guys.